All right, class, here is section 1.5, algebra, functions, and composition of functions. Okay, so we want to know, okay, well, we've talked about functions, what they are, how to evaluate them, domain and range, graphs of functions, but is that all we can do with functions? Well, obviously not. Algebra functions simply is talking about the operations on functions. Can we add them, subtract them, multiply them? Of course, right? Functions are simply given by expressions. Look at that. Each function is given by an algebraic expression. We can add them, we can subtract them, multiply them, divide them, and it's really the intuitive way of what it is we would suppose to do with expressions. So here it is. For example, let's go straight to it. Given two random functions, one's a linear function, one's a quadratic function, by the way, what would it mean to find the sum function? Well, the sum function is simply adding the expressions of the two functions. So it simply says take the two functions you see, not multiply them, but add them together. And so when I add expressions, well, it's just that. I add them. There's no anything to do. If you see any like terms, please combine them. Now, of course, it's very nice when you write the terms of an expression as that you put them in what we call the descending order of exponents. So you start with the term with the highest exponent first, and then go one by one. So I see 1x squared plus 2x, and then these are the only ones that can be combined as they are alike. Positive 1 minus 4 is negative 3. Now when I subtract these two functions, the reason why I even wrote the first ones in parentheses is because this time we definitely need to put the second function in parentheses. So again, it takes the first function, subtract the second one. Now remember, I'm subtracting not just one term, but everything in that function. So when I subtract the x squared, fine. But when I subtract the negative 4, be very careful. It turns into a positive 4. So combining like terms now is going to get us a positive 5 between the 1 minus 4, which is then a 5. So be very careful with that. We're getting a whole new function. So each single time it says we create new functions out of old ones. We create new functions out of old ones by using those operations between their expressions. Multiplying might be a little bit tricky, and it would require you to remember, and if not, here it is, we're practicing. Distributing, okay, so what is 2x times an x squared? So you have 2, the numerical factor, but what is an x times an x squared? That simply means an x times 2 more x factors, which is an x to the power of 3. Okay. Then a 2x times negative 4 is 2 times negative 4 is negative 8x. Then move on to this one and multiply it to everything that follows. So you multiply the 2 to everything. Now you multiply the 1 to everything. So here it is. Now, if you look at this, there are really no like terms in here. You can leave the answer as it is. That's its simplest form. If you want to rearrange the terms, that's fine. In other words, write the x squared in front of the negative 8x. That's okay, but you don't have to. The one thing that definitely should be done is to simplify the expression. So if you see any like terms like the 1 added to the 4 before, we know that's 5. So write 5 instead, yes. So there's that. And finally, division between functions is just that. Take the function f, that's at the front, and divide it by the function g, because that's the one that follows. And that's all you get, simply a fraction that cannot, by the way, be simplified. This is that, and that's all there is. Okay. So that's the boring stuff. Okay, fine. I've added functions, I've subtracted them. That's okay. Nothing really new. But what is new about functions is composition of functions. That is an operation that is specific only to functions. Okay, so what is a composition of functions? That's really what we want to concentrate this section on. So here it is. When the output of one function is used as the input of another, we call the entire operation a composition of two functions. So in general, composition is not commutative. That's what it says here. Composition is not commutative. In other words, the order matters. Okay. All right, so it's right here, also copied out of your textbook, the definition of compositions of functions. So really what this simply means is, again, remember, a function is really like a machine. You put something in, the input, the function does whatever it does, and it just spits an output. Now, a composition is really two machines that work in order. So what this composition here simply says is this, that the function g is the one that's working first on x. So your input is an x, it goes through the function g, and whatever the function g does, it spits out g of x. Now you're going to let this whole g of x go through the function f next. So what this function f does is acting on g, right? And it's spitting out f of my new input g of x. Okay, so it's one function at a time working on these values. So let's see how this works. So for example, here it is. This table of values might be a little bit tricky, but here it is. What is f of g of 2? So that means what? In the function g, we're plugging in the x value of 2. Here's an x value of 2. I'm looking at what's g of 2. Well, that's not going to work well. I cut off a big piece of this table to make it short, and now it doesn't quite work. So here it is. G of 2 is 1. So I'm changing this. G of 2 is 1. So I'm substituting g of 2 with 1. Now, the next thing I want to do is find f of 1. So what is f of 1? That means in the function f, I'm putting an input of 1 now. So if x is 1, what is f of 1? That would be 4. Okay. Let's try and figure out what's g of f of 2. So that simply means f of 2. So look at this function and plug in 2 in the function f first. Now if I plug a 2 in the function f first, what I am going to get is a 3. Okay, great. That means, again, f of 2 is 3, right? If x is 2, f of 2 is 3. We've read tables in 1.1. Now, that answer comes up to be 3. Now, this 3 has to be further plugged in through the function g. Great. Okay, so now x is 3, and I'm plugging in through the function g. So what's g when x is 3? That would be 5. Okay. Let's see what is, let's try one more. What is g of f of 1? Okay, so here it is, f of 1. Let me delete everything else so that we don't get confused. What's f of 1? So x is 1. When x is 1, f of 1 is 4. Okay. Now this statement here says, okay, now plug in 4 through the function g. So that means x is 4. What is f g of 4? That would be 14. So you have to do two operations one at a time. You start on the inside of the parentheses, you do that operation first. So let's try this again. What would be g of f of 3? So this time I'm reading graphs. Okay, so what do I look at? I'm looking on the graph of the function f of x. And it says, what is f of 3? So my input for x is 3. Look on the function f of x at when x is 3, and you're going to find what? You're going to find 1. Now, we're not done because there's a second machine that says, now plug in this 1 into the function g. Great. So, now the input for the function g is 1. So x is 1. Plug it into the function g. What do we get for an answer? Well, it's a little bit maybe lower than -1, but we're just going to say -1. Okay. Let's try this again. Let's start with an f. What is f of g of 0? Okay. So we're starting the story again with g of 0. So x is 0. Look on the function g. What do you see? You see -1. Ish. Now plug in -1 into the function f of x. The blue one, right? What is f of -1? It very much looks like a 3. Here it is. What is g of f of 2? So look at the graph where x is 2 and read f of 2. Well, f of 2 looks like it's 2, right? Now take that and put it through the g function. Now at 2, g of 2 looks like, again, it's -1. All right, here's another graph I'm going to let you read. And I'm going to ask you a few questions, such as, what is g of f of 0? What is f of g of 2? And maybe one more. F of g of negative 2. So look through, and then let's compare answers. So here it is. G of f of 0. So I'm starting at f of 0 and plug in x of 0 into the function f. You're going to see a negative 3, yes? Okay, what is g at negative 3? G at negative 3 is about negative 0.5. Okay, let's try this again. Let's start at g of 2. So I'm starting on the red graph. G of 2 is 2. Well, what if I now further plug in 2 in the function f? When I plug in 2 in the function f, I'm going to get a negative 2. Okay, let's try this last one. What is g of negative 2? So x is negative 2. G of negative 2 actually happens to be 0. Now this 0 has to further be plugged in through the function f. So what is f of 0? We had it earlier. That's negative 3. Okay, so again, it's two functions, a composition. They both work on our input one at a time. So a first function is working on the input, spits out an output. That new output, that output is the new input for the second function. So let's find these compositions in general, and then maybe we'll specifically put in a value. Let's just do this for a second. Let's just specifically put in some numbers. This time I don't have tables of values. I don't have graphs. I have the equations. So what does this statement here say? This statement here says, leave the f for now. The first thing you want to do is plug in a 2 into the g function. So when I plug in a 2 into the g function, this is what that gives me. 2 squared minus 4, which, by the way, is going to get me a 0. Yes? 4 minus 4 is 0. Now that we got the output, the answer, plug in this value as an input for the function f. So f of 0 is 2 times 0 plus 1, which is just 1. So this is how that works. Now, if I want to plug in the whole function in general, here it is. I'm not substituting anything in this function g. It's just x squared minus 4. G of x is just x squared minus 4. There's no value for me to plug in or change. So whatever x is, square it, and then minus 4. That's what g of x is, right? There it is. Now it says take this and put it as your new input in the function x. So not a specific value, but remember we plugged in x plus h earlier. So here it says take this x squared minus 4 and in the function f, plug it in for x. So the function f says it's always 2 times whatever comes its way, and that's what came its way, x squared minus 4, and then plus 1. So if you simplify this a little bit, you're going to get a 2x squared minus 8 plus 1, which simplifies to a 2x squared minus 7, right? Combining like terms. All right. I'm looking for a little bit of room. It's also asking me to find g of f of x. So for this, I'm leaving f of x alone, and f of x is 2x plus 1. So that's what I'm substituting f of x with. Okay. And now it says take all of this and plug it in the function g. Now what does the function g do? Wherever it sees an x, it squares it. So plug in 2x plus 1, where you see the x. Now it says square that, and then minus 4. You can totally leave the answer as it is. You don't need to simplify it, really. I just want to make sure that you're plugging it correctly. That's my interest right now. So, of course, you can multiply 2x plus 1 to 2x plus 1, distribute, combine like terms, but just leave it. You don't need to simplify it. So what a composition of function is just simply a substitution problem. So I'm substituting g of x in the function f of x for x, and then I'm substituting f of x into the function g in place of x. So it just plug one into the other and backwards. It's just the substitution problem. It's just that we're not substituting numbers, we're substituting whole expressions. So let's try that again. Here are my two functions. What is f of g of x? So that simply means take g of x, which by the way is x plus 1, and plug it in the function f. So we already practiced this, where we were starting to plug in not just numbers into functions, but other names, other variables, other expressions, right? It doesn't always have to be a number. So in the function f, where I see x, I now write the g function, which is x plus 1. And this can easily substitute to an x plus 3. Okay, let's go backwards. So I'm substituting f of x first. And f of x is the square root of x plus 2 right here. Now, what does the g function do? The g function adds 1 to whatever comes its way. So what came its way for x is the square root of x plus 2. That's what I plug in. And then the function g adds 1. That's its role, to add 1 to any input values. So this 1 cannot be added to 2 because 2 is inside the square root. The 1 is not. It's on the outside. So that's the answer right there. That's it. So here, just to try, what would be, for example, g of f of 7. So what it says is, first of all, figure out f of 7. Well, f of 7 is the square root of 7 plus 2. And the square root of 7 plus 2, that's the square root of 9. And the square root of 9 is 3. So now it says, the second step is take that output that you had from the function f and plug it through the function g. And the function g always adds 1 to whatever comes its way. So then that makes it a 4. All right, so it's two problems, one after the other. The order matters. So here's your last one. Find f of g of x, and then find g of f of x. So plug in one at a time. Well, g of x is x squared. So in the function f, I have to substitute x with x squared. So the function f takes the square root of anything that comes its way. So if you do remember anything from algebra, is that a square and a square root cancel each other out. They're inverse functions of each other, which is really what is another topic on functions, inverses. So these are functions that undo each other. So again, think about the square root of 3 squared. What is 3 squared? 3 times 3 is 9. And then to find the square root means to find what times itself is 9. The 3 that I just did, right? So as you see, a square and a square root cancel each other out. Now let's do this again, where I'm substituting first the function f of x, which is a square root function. And what the function g does is that it squares anything that comes its way. And by the way, again, a square and a square root cancel each other out in any order. So again, I can think about, let's start with the square root of 9 that is then being squared. What is the square root of 9 first? Is 3. And then when I square that, I'm going to get back the 9 I started with, right? So one function is squaring, the other one is square rooting, so it's undoing exactly what the first function did. We call such functions inverses of each other. Sorry about my writing with the pen here with the stylus. So inverses of each other. And we're going to have a whole section of it, but we'll gather a little bit more algebra in between. We'll talk about inverse functions in chapter 6, the beginning of that. So there it is, done.